Well, it's great to see you all. This slide here just gives an overview of what we're going to talk about today. The theme is how, as we decarbonise several different parts of our lives and the UK economy in general, how these different areas are becoming more and more interconnected. I've borrowed this jigsaw picture from a report I wrote for my work, and we're going to cover some of the topics represented by the different jigsaw pieces, but not all of them. Firstly, I'll start with who I am, and assuming you can help me remember that, we'll move on to the topics listed here. Through all of these, I'll touch on what government is doing in each area and what industry is doing, or what new technologies are being developed in the different areas as well. And I'll close with some thoughts on the role that the government should be playing more generally, and some action ideas, because I understand that's what each of these sessions should include, is some takeaway actions that that we can all be doing. I've put several ideas, and if you can do all of them, I'm sure that's great, but I was thinking you could pick and choose from the list I've come up with. So, next slide. So I think most of you know who I am, and you certainly know my parents, Alan and Delisa Jones. This is a holiday photo of us in the Lake District, and you can see my wife Izzy in the sort of purple blue coat, and my sister, who lives in Cambridgeshire, and her husband in the red coat in the background there. You may have seen us or met us in Selkirk Parish Church back in the era when we were allowed to visit. Hopefully we'll be back again soon. As well as having a wonderful family, I'm a chartered engineer, and I work as a consultant in energy efficiency and renewable energy, particularly in buildings. And I've been doing that for almost 15 years now. A bit later, I'll explain a bit about some of the work I've done recently to help the Scottish Government develop a new version of the building regulation that limits carbon emissions from buildings. And this photo here shows some familiar faces helping me to insulate the room that I'm actually sat in now. Our house is about 115 years old, I think, and it's got solid brick walls, which we've fully insulated internally. And I've written a blog about it, so if you'd like to read any more about that, there's a link at the bottom, but you can ask me questions about that later as well. And the other thing about me that I thought I'd share is, for the last 18 months or so, I've been the environment officer for the church that Izzy and I attend in Leeds. And over the last 6 months particularly, we've been running a series of Zoom sessions, a little like this one, on a range of different topics, and these are all recorded, so you can watch them on the website there if you're interested in those as well. So generally, I like to try and focus on the big things first, rather than getting too distracted by small issues. I apply that to climate change, but other things as well. This pie chart shows the approximate breakdown of the UK CO2 emissions into different sectors. And you can see that the three largest parts are transport, electricity, and heat. So those are the three areas that I was going to focus on today. Just going to have a drink of water. Okay. So for a long time now, we've tended to think about these three areas separately. The way the government is organised and businesses organise themselves tends to reflect this too. So we've got a department for transport and regulations for electricity. But there's always been a little bit of overlap, but it's generally been quite limited. So, for example, you may use electric storage heaters, so that would be an overlap between electricity and heating. And in terms of transport, we've had electric trains for a long time, but it's a relatively small part of all the transport going on in the UK. But now these are becoming much more interconnected areas, and this will continue to increase as we decarbonize the economy further. So I'm going to explore some of the ways that that's happening. So we're going to look at the new ways these areas are starting to overlap more and more as we're looking at these different areas individually as well. So some of the new areas for overlap are things that you may have heard of or may be familiar with. So heat pumps, and I'll explain a bit more about what they are in a moment. Electric vehicles, which you may be a bit more familiar with. Hydrogen, which is getting a lot of media coverage, and then something called the smart grid, which I'll try and explain a little bit more about as well. So let's start with electricity. This graph shows how the source of our electricity in the UK has changed over the last 100 years. Over most of this time, the electricity has come from 3 fossil fuels: coal, oil, and gas, shown in 2 shades of grey, and then the purple pinky colour showing gas. But if we look at 2020, at the extreme right of the graph, we can see that we're now getting less than half of our electricity from these fossil fuels. The demand has fallen a little bit, and wind turbines in particular are making a big contribution. The carbon emissions from electricity have approximately halved in the last 5 years, and most people are barely aware that this has happened. One of the effects of this is that it's now lower carbon to use electricity than gas. So Izzy and I recently changed our gas cooker for an electric one. This graph is for the whole of the UK, but much of the UK's renewables are in Scotland. So your electricity is generally greener than ours. But the approach that Scotland's taken to get there arguably is only working because the surplus renewable generation is spilt down into England, if you like, at times when supply and demand aren't matched up in Scotland. Without this, a lot of the Scottish wind farms would have to turn off or reduce their output when local demand isn't enough to soak up everything that they are producing. But we need to go beyond that because the whole of the UK needs to go as far as Scotland has gone in terms of renewable generation. So we need solutions that don't just rely on spilling the power from one area to another. If you're interested in this area and how the grid varies dynamically, I can recommend this app that you can get for a smartphone, Android or iPhone, it works. It gives you an update on what the UK grid is doing every 5 minutes, and you can look at it and see the percentage coming from different sources. So I could give you an update right now. And it hasn't been very windy recently, so wind has been doing very little. So wind is currently doing 3% of the total, and we're getting 57 from gas. And obviously the sun's going down, so the solar's doing very little. But it can be much higher, and I've seen wind and solar between them supplying about 50% of our demand, and with other bits from nuclear and biomass. And we import and export electricity between other countries as well, which you can see here. French and Dutch interconnectors, which I'll talk about in a moment. So this graph is taken from the app, shows how the electricity grid is managed on a typical windy day. As far as possible, the wind and solar, shown in green and yellow, are allowed to contribute all they can. We get a bit from nuclear, which is basically always on, that's shown in light brown, and a few other things. But what's making it all work at the moment is that gas, shown in the darker shade of blue, is rapidly responding to fill the varying gap between supply and demand. Without this rapid response, the system would fail because there's very little storage, so supply and demand need to be matched all the time. Another important aspect of this is interconnectors, which link the UK electricity system to those in other countries. These allow us to import and export power to help us balance that electricity system, both here, and it helps the other countries as well. This map is slightly out of date, so the green links and most of the blue links are operational. The one labelled IFA2 down here, connecting us to France, turned on earlier this year, and the link to Norway will turn on later this year. The ones shown in purple and yellow are proposed but not built yet. There's also some planning for a link to Iceland, but that's a particularly challenging project. It's a long way. And Iceland has a lot of very cheap renewable electricity. It's arguably the greenest grid of any country in the world. It's almost purely hydroelectric and geothermal. So you may remember that last November there was a bit of a fanfare around a 10-point plan to decarbonise the UK. And I just wanted to read you a short section from this. The UK already generates more electricity from offshore wind than any other country. Government support to unleash the potential of this industry has seen the cost of offshore wind fall by 2/3 in the last 5 years. To offer further commitment to the industry and help further reduce costs next year, so this year, we will aim to deliver up to double the amount of renewables we procure through our next contract for difference auction, and I'll explain a bit about that in a moment. And by 2030, we aim to produce 40 gigawatts of offshore wind, including 1 gigawatt from innovative floating offshore wind in the windiest parts of our seas. So 40 gigawatts, that's the rated output of the turbine. So it's the amount they'd output when it's really windy. Obviously, it's not windy the whole time, but 40 gigawatts is about our peak usage on a typical day. So if it's a windy day, that's saying wind alone, forget solar, forget nuclear, all the other stuff, could do everything. And they're billing that as a quadrupling of our current offshore wind capacity. That is correct, but it's just to sort of slightly moderate that statement. If you count existing onshore wind as well, then it's more like triple, but it's still a big step change. And when you read into the detail, there isn't a huge amount of government money actually going into achieving this target. And that's because, as they said in the quote, the price of offshore wind has fallen and is continuing to fall really quickly. The UK government is claiming some credit for this, and they refer to something called a contract for difference auction. This isn't my area of expertise, but essentially companies are asked to bid in a blind auction for the right to build wind farms in certain areas of the sea that the government has earmarked for that purpose. And I understand that the way that the UK has been doing this is now being copied by lots of other countries because it's working so well at bringing the prices down. This graph shows the cost of offshore wind falling faster than other sources of electricity. And you can see solar's coming down a bit as well. That's more of a global trend because the factories are all over the place. But offshore wind relies on a lot of local expertise with the right equipment in ports, the right sort of ships. There was a really great BBC documentary called something like Powering Great Britain a few months ago. I think it's not available at the moment, but you may keep an eye out for it. But it showed the process of building offshore wind farms. And they've got the process now such that once the foundations are in place, they can construct the bit above the foundations in, it was something like 20 hours from the point that they turn up with the bits and the turbines up and running, which is just phenomenal when it's a huge turbine that generates several megawatts. So that's electricity. Let's move on to buildings. This pie chart shows the typical breakdown of the carbon emissions from using energy, normally in the form of gas and electricity, in our house. There are other building types, obviously, shops, offices, schools, hospitals, and they'll all have a different breakdown. And actually, each house will be different because the people living in each house have different behavior patterns, and the fabric of the building and the heating system will all be different. But if we're each able to work out our own versions of this pie chart, it would show something fairly similar. And what you can see here is that in most cases, the heat for heating and hot water is likely to be a big part of the total. One of the reasons here is that, as I've explained a moment ago, electricity is getting greener. So the carbon emissions from our electricity are becoming a smaller part of the pie chart. Even if we're using the same amount of energy, it's less carbon, and this chart is showing carbon rather than energy. In essence, the UK is a fair way along the path to a low or zero carbon electricity supply, but decarbonising heat is a very different challenge. All the UK government, or different governments in the UK, I should say, are putting a lot of effort into decarbonising heat, not just in our homes, but in all the other places that we use it as well, including industry, which often needs very high temperatures. This chart's from a fairly recent government report, and it's showing that at a national level, if you take all kinds of heat, and they're including cooling there, so thermal energy, it's over a third of the nation's carbon emissions. A big chunk of that is industrial heat that's often requiring very high temperatures, which I'll touch on a bit later. So one of the tools that I mentioned earlier that's going to play a big part in decarbonising heat is something that you may have heard of called a heat pump. And there are lots of types of these, but I thought I'd give a really simple explanation of how they work. Firstly, just to remind us how a gas or oil or LPG boiler works, we take the fuel, we burn it, a small amount of the heat goes up the chimney or the flue as warm gases, but most of it, perhaps 90%, is used to heat water, which we use for heating or washing. And I've shown some simple maths here. 1 unit of fuel goes in, 0.1 escapes, and we end up with 0.9 units of useful heat. Heat pumps generally run on electricity, but rather than letting the heat escape into the outside air, they can absorb heat from the air. So they take air and they cool it down and then reject that cooler air. Typically, they can absorb a lot of heat from this air. So we end up with perhaps 3 times the amount of heat coming out of the unit compared to the electricity that we put in. It sounds a bit like magic, but as an engineer, I can assure you it's not. I can explain how it does it if you're interested, but it would take a bit too long to go into that right now. So combined with a low carbon electricity grid, this becomes a really effective way to decarbonize heat in buildings, but they currently cost a lot, the upfront cost, and there are lots of pitfalls in how to install them and operate them. So we need training for designers, for installers, and for homeowners to make them work at their best. And we need the manufacturers to work out how to bring the costs down as well. And this will happen, a bit like we just saw with wind, as the demand increases. Another tool to help us decarbonize heat is something called district heating. This isn't a new idea. It used to be quite widely used in the UK until around the 60s, when we found a lot of cheap gas in the North Sea. And it is still widely used in Scandinavia and lots of other countries. The idea is that rather than having a boiler in each building, we have a big central source of heat, and we use it to supply hot water through a network of insulated pipes buried in the street. Here's a photo of a system being built in the centre of Leeds, which I took for my work a few months back. The construction cost is quite high. Anything that involves digging costs quite a lot. And the pipes do lose some heat as they run the heat around between buildings. But the advantages are that it gives each building access to a low carbon, low cost source of heat that they might not otherwise be able to use. So for example, waste heat from a factory, or heat from a low carbon technology that's just too big to put in an individual building. So the Leeds district heat network is supplied through waste incineration. The black bin waste goes to the building pictured here at the top, and it's sorted to remove anything that ought to have gone in the recycling. The remainder is burnt, and you might be concerned about the fumes from this, but a third of the volume of that building is occupied by a fume filtration system, which aims to remove all the worrying chemicals before they go up the chimney. The energy from burning the rubbish is used to generate electricity and heat. The electricity goes into the national grid, and the heat is piped into the city centre in those insulated pipes. Lots of these networks are being built all around the UK with government support. Each network can take several years to get from an initial concept through to construction. And at the moment, the heat market isn't regulated, but that regulation will be coming soon. So that's another thing that the government's doing about that to protect consumers. And this might be done in a way that requires buildings near the network to connect, or to switch to another low carbon source, perhaps a heat pump, if they choose not to connect. District heat networks are primarily a solution for urban areas where the distances between buildings are short and the sizes of the heat demands tend to be high. But government is funding feasibility studies for these and then putting money into the construction of them as well, but in a way that when the network has a high enough financial return for the private sector to run it, then government isn't subsidizing that in the same way. Over some of the last year or so, I've been doing a piece of work for the Scottish Government to help develop their plans for changes to the building regulations, which relate to energy and carbon. I've been part of the team doing this for Scotland, for England, Wales, and the Republic of Ireland. And whilst there are differences between the approaches, there's a lot of similarities too, and the different UK administrations share a lot of resources and information to save them all time and money, so they don't do the same analysis twice. The process that this goes through is that we develop proposals, which are then published in a consultation document, and anyone interested can then respond to the consultation by answering a series of questions or just responding with whatever response they want to give as well. These responses are then reviewed, and the proposed changes may be then refined to account for the feedback if there's a lot of evidence that says this change might not quite work in the way you've planned, or it's going to have this unintended consequence. The final version is then published, and about 6 months later it will come into force so that everyone knows what's coming. Whilst I've done this first bit of work, developing the evidence base, the consultation hasn't been published, so I can't tell you much about what it's going to say. But the English equivalent has been published, so I can say that there's going to be a lot of similarities between the two, and that the main points are going to be a general tightening of the energy efficiency standards, and that fossil-fueled heating will be strongly discouraged in new buildings. Government has announced a policy to effectively ban the installation of gas boilers in new buildings from around 2025. And that sends a signal to the industry that they need to respond to make other solutions more viable. And we're seeing that already. And this change that happens before 2025 is sort of a ramping up towards that, if you like. That's all great, but building regulations only affect new buildings or those undergoing a substantial refurbishment or extension. And there are far more existing buildings that all need to improve as well. So there are plans to use other types of legislation other than the building regulations to encourage or require things like fossil fuel boilers perhaps not being replaced like for like, but being replaced with low carbon sources. These are things being thought about. In England at the moment, there's already a minimum energy efficiency standard for rented properties. So you have to have a certain EPC rating, which is an energy performance certificate. You may have, if you've bought or rented a house, you may have seen something like this in the pack of information you get about it. Basically, it's an energy rating for the building. And in England, you're not allowed to rent anything that's rated F or G. And the idea is that that will get tightened every few years. And it encourages landlords to improve their property, energy efficiency of their property. In Scotland, there's a plan for a similar requirement for rented properties, but the legislation was postponed last year because of the pandemic. That applies at the moment to rentals, but there's proposals that should also apply to when properties are being bought and sold as well, and perhaps even being linked to mortgages. And these are ideas that are being explored now. There's a lot of ways that could go wrong, but the idea is there, and that's the direction of travel, at least. So another way to decarbonize heat that is getting a lot of publicity is hydrogen. So I'll explain where this might or might not fit into the picture. The first thing to say here is that hydrogen isn't a source of renewable energy. It's simply a way to store and to transport it. Hydrogen is a gas that can be burnt like the gas that we get piped to our homes, but when it's burnt, it only releases water vapor, not CO2. But the cheapest way to make hydrogen does produce CO2, and all the ways to make it use energy as well, which we may be getting from fossil fuels as well. The first two diagrams here compare two different ways that hydrogen can be made. These two ways are referred to as blue and green hydrogen. These are just names for the process. The gas produced is exactly the same. Blue hydrogen takes methane gas, the gas that we use in boilers and cookers, and puts it through a process called steam reformation, which separates the hydrogen from the gas and then releases a lot of CO2 in the process. In theory, most of this CO2 could be captured and stored, so it doesn't contribute to climate change. But this process hasn't been proven at scale and would add to the cost of production. Green hydrogen is produced by using renewable electricity to split water into hydrogen and oxygen. No CO2 is released at any point, but it costs more to produce it this way. And you can also see from the diagrams that neither of these processes is very efficient. So we're putting in a lot of energy, and energy is becoming a limited resource, and we're not getting the most out of it. I've taken these diagrams from a document produced by an organisation called LETI, which stands for the London Energy Transformation Initiative. Although they're based in London, a lot of what they say applies elsewhere. Their argument from the document is that using hydrogen for heating buildings is so inefficient that we're uncertain, and we're uncertain that it would work, that we shouldn't be pursuing this. In the third diagram, they compare it with using renewable electricity to power a heat pump, as we covered a few minutes ago. This is more efficient and would mean we need much less renewable electricity capacity. I've put the link there if you want to read a bit more about what they say about that. My view on this is that the hype around hydrogen is largely driven by gas companies and the gas network operators who've realised that if the world decarbonises, or the country decarbonises, then their equipment, their gas network, the whole industry will become a dead end unless they can convince the government that this, or something very like it, is a good idea. On the plus side though, hydrogen is useful in that it can be stored for a long time, where electricity can't easily be stored for a long time, using very simple tanks, although a tank can leak and hydrogen is a small atom, so it leaks much more easily than any other gas. And it can also be useful to create very high temperatures for industries that currently use gas. So temperatures a heat pump would never get to, that are needed for producing steel, for glass, or other chemicals. It might be useful for some forms of transport, lorries, ships, and planes perhaps, although we don't yet know if electric batteries will be better for those. The technology is still developing. And there's a challenge in delivering the quantity of energy we need for heating through the electricity grid, and this use of hydrogen would help with that as well. The last of the three circles that we're going to cover is transport. And there are lots of aspects to reducing our emissions from transport. I remember attending one of these sessions a few weeks ago where you were talking about walking and cycling more and using buses and trains instead of cars when we can. I'm not going to talk about these today. I'm not going to say much about transport because I don't know that much about it really. But what I do want to explain is how transport is increasingly linked to electricity and to buildings. I expect you're all familiar with the concept of an electric vehicle. In many ways, the technology is not complicated. It's simply replacing a fuel tank and an internal combustion engine with a battery and an electric motor. The price of electric cars is falling, and for new cars, it's getting close to matching the cost of a fossil-fueled car. And this is because this fall in price is being accelerated by government policies to phase out combustion engines. I and a few others here could talk about the details of this for longer than we have this evening, but there's one particular opportunity that electric vehicles create that I want to explain. And that's the idea of something called vehicle to grid, or V2G. This is the idea that as well as charging your car's battery from the grid, in the future, there'll be the opportunity to sell some of the electricity stored in the battery back to the electricity company at times when there's high demand and when the price is high, which happens at the same time. I'll explain a little bit more about that later. The technology for this is ready to be used, although it is quite expensive, so the charging points cost a lot more. Government and industry are in the process of working out how to change the laws and to create contracts that allow this idea to develop and to flourish. There are some companies with large vehicle fleets which are testing this out, and there are a few residential demonstration schemes in operation already. So it's coming, but it's not there yet. But it's a way to store electricity. If we bought all the batteries for the cars anyway, as a country, can we use them to help balance the grid in solving some of the problems that we were talking about a moment ago? So we've covered a lot of different topics there to explore how they're increasingly interdependent. So almost finally, the idea where all of these different areas combine is something called smart grid. Smart grid is a bit of a buzzword, but that's mostly because the term's getting misused in some areas. It is a genuine thing with some real value. So many of you may already have a smart meter with a display like this one, and you may have seen adverts which say that by getting one that you're going to save energy. In one sense, they don't save energy. All they do is tell you how much you're using. But if you choose to do things to reduce that, or if it gives you information that modifies your behavior, then it can help to reduce energy demand in that way. But that, in my mind, that's not really the big achievement that they can deliver. They're also a key tool in helping to balance the supply and demand of electricity. Smart meters take frequent measurements, meter readings essentially, which means that the information can be used to help us figure out what's using electricity. But it also allows some electricity companies to offer tariffs that change several times during the day in response to what the wholesale minute by minute electricity market is doing. So if we choose a tariff, where's that picture gone? There it is. So there's a company called Octopus that were the first company to bring out a tariff like this. So if we use a tariff like this, then we're more motivated to shift our electricity use to times when the power is cheaper, which would typically be when it's windy, when it's sunny, in the middle of the night when the demand is low, at the weekend when the demand tends to be lower. Very helpfully, when the power is cheaper, it's also greener, and that's because getting energy out of a wind turbine or a solar panel doesn't cost anything. Once you've built the equipment costs money, but getting the energy out doesn't cost anything. The wind and the sun are free. So when it's windy and sunny, electricity is cheaper. When those things stop, then you're paying for gas or for coal or the operation of a nuclear power station in a way that costs more. So helpfully, price and carbon tend to go up and down at the same times. So if we save money, which we're all motivated to do, we tend to be saving carbon. So governments have a key role to play in taking away risk. If the government says that new buildings can't have gas boilers and more heat pumps and district heating networks will be used, then businesses working in those areas have the confidence to invest in training and equipment and new products and all the other things they do to make those solutions cheaper and more accessible. Just to illustrate that, a really bad example of when this went wrong is something called the Green Homes Grant, which you may have heard about. It was rushed out. It was announced, I think it was June or July last year, as a COVID job creation scheme. It was too short term. The scheme required installers to have certain accreditations, which most of them didn't have. When it was first announced, it was only going to last for a few months. So it was announced in June or July. It came in September. It was going to run out in March this year, so what's that, about 6 months, it was only going to last for a few months, which wasn't enough time to get the accreditations and make the investment back. So all the installers who didn't have the accreditations just gave up on that idea. Then the scheme was announced that it would be extended by a year, but it was still barely long enough to make the training worthwhile. And then the scheme in the last few weeks, I think, was scrapped because it wasn't working. People weren't taking it up. People were finding it very difficult to get money out of the government for the scheme. And this is where it's entirely counterproductive, some installers apparently went bust because they'd done work and they weren't getting paid. And the capacity of the market to deliver the solutions we need is then reduced. So I've lost my place in my notes. Where are we? Yes. So longer term policy announcements that are better thought out will be more successful. And it can be frustrating to see the sort of long-term announcements that governments make and think, well, we need to be decarbonising quickly, we need to change quickly, and you're looking at 5 years, 10 years. I think because the target is, I don't know, gas boilers in 5 years' time being ruled out for new buildings, that's a long time, but the market needs some time to respond. And it's not that nothing's going to happen during that 5 years until that new legislation comes in, but the government needs to have that long-term view in order to take the risk out of it for businesses to do the things that takes that time. So there's a few things that are coming down the line. The UK will be banning the sale of pure combustion cars from 2030, and some hybrids can be sold until 2035. The UK will effectively ban gas boilers in new buildings from 2025, but will be strongly encouraging them from next year. The UK will triple wind energy by 2030. And all these are longer term announcements that the industry is already responding to. So they're not going to build all those turbines in 2030. They will be built starting probably in the next year or two. But we need something equivalent for home and other building refurbishment. And this is really a key policy gap at the moment. So I hope that's been helpful. I've listed out a few things that we can perhaps take away as actions or ideas for actions. So campaigning for more government support, particularly for building refurbishment, because I think that's a big gap. So insulating buildings is the main thing there. Investigating lower carbon heating options. As I said, heat pumps are quite expensive. And as individuals, you're not going to go out and build a district heat network. You're not going to go out and build a hydrogen plant. It's unlikely. So a heat pump essentially is the option you've got as an individual. And if that doesn't work for you, if the government supports that there is something called the Renewable Heat Incentive, if that doesn't work for you, get in touch with politicians to say, I want to do this, but I can't because I can't afford this, or the subsidy's not enough, or I can't find an installer. Explain what the problem is and ask them to do things to address that problem. A simple thing we can do is switch to a renewable electricity tariff. There is a pitfall there. If you think back a couple of slides, you'll remember that less than half of our electricity comes from fossil fuels now. And many electricity companies sneakily take the view that as long as less than half the electricity they sell is going to customers on renewable tariffs, then they don't really need to change anything. Which magazine wrote an article on this, which I really recommend reading. The links there at the bottom. Their basic conclusion was that, as far as they could tell, the two companies pictured there at the bottom, Ecotricity and Good Energy, were the ones that they could identify were definitely making a positive difference, using their customers' payments to invest in renewable stuff. That article was from 2019. Stuff will have changed a bit. And the article actually says some companies didn't give us the information we needed to make a judgment. So I'm not saying they're the only ones, but they were the only ones the article could confidently identify. If you have a smart meter, try and look at what it's telling you and see if it can help you save energy. There might be things that you're leaving on and not realizing how much impact it's having. If you're interested, have a look at the Grid Carbon app I mentioned, and you might like to look at when electricity is green and move your big consuming items, which you'll be able to identify with the smart meter, move that behavior to times when it's greener. So if you've got a car, charge it when it's greener. If you've got some laundry to do, look at when the grid's greener to do that. Those sorts of things. Perhaps consider switching your cooking to electric rather than gas. Don't underestimate the complexity of that. Speak to an electrician. It's not just a case of buying something and putting it in there. If you haven't got the wiring, as we hadn't, then you need the wiring to run it off as well. So yeah, when you're costing that up, speak to an electrician as well. It's not just going to Currys and buying something. And then if you're really keen, look out for something called the Section 6 consultation, which is the change to the building regulations that I mentioned that I've fed into, and you're all entitled to respond to that. What they often do is present two options, and you might want to respond and say, yeah, go for the green one. The green one's the best one, and give them some reasons for it. Even if you don't have a strong argument based on experience, your opinion still counts. It's a democratic process. So yeah, that's all that I prepared to say. And gosh, 45 minutes, well over the target 20, but I hope it's all been helpful.